In this example, we will go over recognizing types of expressions. First polynomials, and then exponentials. Polynomial is an expression of finite length constructed from variables and constants using only addition, subtraction, multiplication, and non-negative whole number exponents. So there's no division, and there's no negative exponents in a polynomial. A monomial is a division of polynomial where instead of having length as long as we want only has one section, so to speak. For example, for the first question, which of the following are monomials, we have a, which is 4ab squared c. There's no division, there's no negative exponents, and there's not more than one term. There's no addition or subtraction, so we know that this is a monomial. However, for b, which is x squared plus y, even though we have only positive exponents and no division, we do have this addition sign, which means we have become a polynomial, not a monomial, so this is not a monomial. Using the same ideas, this is a monomial, letter C, since there's only one term. D is not a monomial, since we have addition and division. And F is also not a monomial. Actually, F is a monomial because the sixth we can consider as just a 1/6, which is in fact a constant. So this is a monomial. Don't let division trick you like it almost did to me. Just because there is division doesn't mean it's wrong. It's just division by variables that's wrong for a monomial. For the second question, we're asked which of the following are polynomials. Polynomials, like we said before, can have addition and subtraction. They just cannot have negative exponents or a division of variables. For letter A, we have 5a squared b to the 5th. This is a polynomial. It also happens to be a monomial. It's kind of a subset of polynomial. B, we have x to the 4th minus 6x over y. Since there's a y in the denominator, this cannot be a polynomial. For C, we have p squared plus p minus 12. And since this is a polynomial, we can have addition and subtraction, so this is correct for a polynomial. For D, we have 3 to the x minus 2. This would be okay, except for that our exponent is not a whole number. It is, in fact, a variable, so this cannot be a polynomial. For E, we have 5x squared y minus 3x plus y. Since all of the exponents are whole numbers, and since we only have addition and subtraction with no division of variables, this is a polynomial. For exponentials, there are two different kind of definitions for it. One is more loosely based than the other. An exponential function is essentially a function where e, the number e, is used, and it's used to model like phenomena when constant change and independent variables can occur. That's the more formal definition. We also use exponential to describe any sort of function where that's of the form cb to the x, where b is any positive real number, not necessarily just e, but it's raised to a variable. Thus, its exponential is not just that it has an exponent, but rather that it is raised to a variable. Using these definitions, we're going to use the looser definition. We see that A and C both do not have exponents in their, or do not have variables in their exponents, so these cannot be exponential. B is the very formal definition. It in fact uses e to the x squared plus 1, which is definitely exponential. Letter E, although it is not With the formal definition, both it and b do have variables in their exponents, so we do consider them to be exponential functions. And all exponential functions will have a graph that looks something like this. This is going to be for e to the x, which is the definitional exponential function, where we start at negative infinity and then rise exponentially as we go out to positive infinity. And this is, again, the function y equals e to the x. And these kind of functions are used to model things like exponential growth, exponential decay, etc.